path enthusiasts, welcome to the lecture series. Hope all of you are doing well. So, in our previous sessions, as you must recall, we had discussed about receptor signaling, how a cell responds to a stressor in a generalized manner. So, from today onwards, we are going to focus on different conditions and how a cell responds to these conditions. So today we are going to focus on oncotic necrosis. So as we recall from our previous posts that cellular injury, whenever there is acute stress, a cell, though it gets injured, but it has a capacity to adapt itself back to normalcy. But when the stress levels are prolonged, there are irreversible injury which leads to necrosis. Now today we are going to study the mechanism of necrosis. So when there is necrosis in the cell, there is hypoxic condition, which means less oxygen at the ischemic perfused site of the tissue, and this decreased oxygen would directly act on the mitochondria and decrease uncoupling reaction of oxidative phosphorylation, which dis- which means disabling of conversion of ADP to ATP. So less ATP is formed, which leads to decrease in the sodium potassium pump of the cell. As a result, there is high calcium influx, leading to swelling and loss of volume control of the cell. The calcium influx also happens in the mitochondria as there is so transitioning of mitochondrial membrane permeability. So this layer of the mitochondrial membrane becomes so thin that there is increased calcium influx and release of reactive oxidation species and nitric oxide scavengers, and also activated hydrolytic enzymes like phospholipases, proteases, ATPases, RNases, and exonucleases. All these enzymes collectively digest the dead cellular components present in the cell after the injury. Now, these reactive oxidation species facilitate healing and repair of the cell that is much needed after this injury. So, in the next class, we would focus on how This reactive oxidation species facilitate healing and repair. Until then, have a nice day.